11.3 is the slightly tougher one. Slightly tougher one. So if you have been sleeping or you have not been paying attention, please wake your friend up. Okay. Now 11.3 up. Now we want to deduce y to the square root graph. Okay. Actually, square root may seem easy, may seem difficult, but let's look. Have attention. Or look up. Now we have this graph, y equals to this. If we take square root, can we all zoom into something here? All we need to do is to take square roots of all the y coordinates. Am I right? Quite easy. Quite easy. Look here. That means you will take square root of all the y coordinates. What about these two sections? What happens? You cannot square root negative numbers, right? So if this exists for all x, when you take square root, you can't square root all these numbers, the y coordinates, the negative y coordinates. So it will be cut off like that. It will be cut off like that. So the square root graph only comprises of this. Do you follow what I'm saying? Why? Cannot. Why so short? Can Okay, I want to highlight one very important, but I will say it time and again, and I will explain why later. We all should note that at this point, at the x-intercept here, the tangents are vertical. Okay, I repeat one more time. The tangents here are vertical. That means when you sketch this shape of the graph, this must be vertical tangent. You must, when you zoom in a little bit more, you should see that this is a shape vertical like that. Correct? As a vertical tangent loop. I will refer it as a vertical tangent loop. As to why, I will explain later. Alright? As to why, I will explain later. Okay. Explanation on a blank page. All the ideas. Okay, now let's use a simple example. Y equals to x plus 2 again. I like to use this one, and y equals to square root x plus 2. This is easy. And we all know that in order to deduce, or look up, in order to deduce the square root function, I am going to take all the take square root of all the y coordinates. So this is negative 2, 0. So I'm going to put negative 2, 0, and then it looks like that. I am going to explain why is this portion shaped like that. Okay? Okay. Now, I need to sit down. Okay, let's see. Can we say this? Dy dx, we can differentiate equals to 1. Fair enough. Now, what is this dy dx? Dy dx is half x plus 2, negative half, and then a 1. Am I right? So, equals to 1 over 2 square root x plus 2. Now we have it. I think we have the answer. Why? Because, look very carefully, at x equals to negative 2, if I substitute negative 2 here, my denominator is 0. That means I just want to divide by 0 like that. Undefined. That means it is a vertical line. Correct? A vertical line has undefined gradient, right? Then you will tell A, you think G, you use a simple graph. Correct? Correct? Use a simple graph. Of course, undefined. Let us then use a general graph. That means I'm saying now, okay, fine, I don't want this. I say this is fx. I don't want this. I say this is fx. What happens now? Now it's slightly trickier. Okay, suppose we don't know what is this, but we definitely know at x equals -2, y is 0. And x equals -2, y is 0. This one, square root of 0, you get 0. But what we want to find out is at the gradient, at this point, what is the gradient? Do you follow what I'm saying? Okay. Now, at this point, dy dx equals to f prime x. At x equals to -2, f prime -2, what is it? Suppose we take on some value equals to, say, maybe a lah. For whatever a lah. That means what I'm saying is at this point the gradient is a. That's all. I don't care what is it. Because I don't know what is this function, right? But at least it's not 0 lah. And it's a. It can be positive, it can be negative, doesn't matter. Now, what we want to find out is what is this gradient at this new y. This new y, so this new dy dx. So, can we use chain to differentiate? How? Can, right? Can differentiate or not? Can, right? I bring down the half, and then I say fx to the power of -half, and then I have f prime x. Am I right? Okay, then we rearrange a little bit. We say it is f prime x over 2 square root fx. Can or cannot? So now what do we do? The most important step now, I sub x equals to -2. What is my dy dx at x equals to -2? Which means I want to investigate what is the shape here. What do I get? I will get a, sorry, don't tell me it's hanging now. Oh, no, it's not. Over 2 square root. Am I right? I substitute x to -2. Now, what is crucial is this. At f prime -2, sorry, f prime -2 here, it is some value a which I go for, some finite. Not 0, but it's a bit positive. Divide by 2 over f -2. What is f -2? 0 again. So I get a number divided by 0. What do I get? So I will always get a vertical. Whenever I get a x-intercept here. But what is the important condition here? Shall we not forget that the important condition is this, At this original graph y equals fx, at the x-intercept, the gradient is not 0. It's some number a. This is a. If this is 0, that means a minimum point or something. You get 0 divided by 0. You get 0 divided by 0. That is the part that we need to investigate more. I'll be worried about that later. Okay? So we assume that, okay, if it's not a stationary point, a divided by 0, I will get a vertical tangent. Okay? Okay? All these are in your notes. Really. They're all in your notes. I show you. Here, all here. Okay? So don't have to copy it really. But you must understand. Follow? Can follow? So I'm not going to explain all those things in your notes anymore, okay? Can? Okay. Let me then very quickly, sorry. Now, let's see, can I have attention? So now, if I have y equals to x plus 2, how do I deduce y equals to square root x plus 2? Now, step 1, we all like step-by-step guide. I eliminate this part. I can't take negative square root. Square root of negative values. So my graph only my graph only exists for, actually this one not very good. Okay. My graph only exists for this portion. So I will take square root of all these y coordinates. Now one important point to note is, you press your calculator, square root of 4, do you have a number bigger than 4 or smaller than 4? Smaller. Square root of 5, you get a number bigger than 5 or smaller than 5? Smaller. Square root of negative, square root of 0.5, you get a number bigger than 0.5 or smaller than 5? Right? Square root of 0.5, what do you get? Bigger. So now it's important. Can? So what is important here is, if I were to sketch y equals to square root, what is interesting is it's like that, you know. This is -1, this is 1. If you take square root of any value between 0 and 1, you will get a number that is bigger. If you can take square root of number bigger than 1, you get a number that is smaller. So what it will end up with is this. Do you follow what I'm saying? That means you take square root of any number smaller than 1, between 0 and 1, you will get a number that is bigger. That means higher than the original one. Okay? Is that idea a question? Why is that so? What is the idea of square root? What times what give you that, right? So 0.7 times 0.7 will give you something like that. That's all. There's no y. Yes. Which one? Which part? Here. 0 to here. Because the y values are bigger than 1. Y values are bigger. You take square root of any number that's bigger than 1, you will get a smaller number. Correct? Right? If you are taking square root of y values, let's not forget you are taking square root of y values, or not x values, yeah? Or taking square root of y values. Okay. Example 4.